Students, today we'll be learning a new topic called Arithmetic Progressions. This is a very important chapter for your class 10. So before we start, we have to understand what is sequence. So for this, let me just write a list of numbers. I'm writing here 2, 4, 6, 8, 10. Next, I'm writing here 1, 3, 5, 7, 9. And I'm writing here 1, 3, 9, 27. Just go on. And one more example, I'll be writing here 1, 4, 9, 16, 25. So let us observe this list of numbers one by one. You please look at the first one now. 2, 4, 6, 8, 10. This is just an arrangement of numbers. But when I arrange the numbers, do I follow any kind of rule? This is 2, this is 4, 6, 8, 10. If I add 2 to the first number, so now let us add and see 2 plus 2. I'm getting here 4. So when I add 2 to the first number, I'm getting the second number. So if I add again here 2, then I'm getting the third number. 4 plus 2, 6. Then here plus 2 again, 6 plus 2, 8. Then again here 2, adding, I'm getting here 10. So I'm just following a rule so that I can obtain the next number. So now let us observe the second one again. 1, 3, 5, 7, 9, and so on. Here 1 plus 2, I'm getting 3. 3 plus 2, I'm getting 5. 5 plus 2, I'm getting 7. Then 7 plus 2, I'm getting here 9. Here also I'm following a rule. And we have arranged the numbers. Look at here again. 1, 3, 9, 27. Do not be surprised. Let us find out, is there any rule obeying here while arranging the numbers? Now the first one is 1. If I multiply this 1 by 3, 1 into 3, 3. Again, if I multiply here by 3, 3 into 3, 9. If I again here multiply by 3, 9 into 3, 27. Here also I am following a rule. And let us look at the last one. 1, 4, 9, 16, 25. What is there actually? So let me take the natural numbers here. 1, 2, 3, 4, 5. First 5 natural numbers I have taken here. Now I find their squares. 1 square, 2 square, 3 square, 4 square, 5 square. 1 square, 1. 2 square, 4. 3 square, 9. 4 square, 16. 5 square, 25. Here also I am following a certain rule. So this kind of arrangement of numbers in a well manner, in an ordered manner, in a proper pattern, by obeying certain rule, is what you call sequence. So whatever the list of numbers I have written here, these are all sequences. So now let me just take the first sequence. So let me rub and write 2, 4, 6, 8, 10. So whatever the numbers present in the sequence is what you call term. That means the elements of the sequence is what you call term. So here how many terms? 1, 2, 3, 4, 5. We have 5 terms. So let me write one more sequence. 1, 4, 7, 10, 13, 1, 2, 3, 4, 5. What do these dots mean? These dots mean that still the numbers continue. That means the second one will have infinite number of terms. Here in the first one we have only 5 terms, but in the second case we have infinite number of terms. So now sequences are divided into 2 types on the basis of number of terms present in them. So in the first one we have 5 terms, that means finite number of terms, but in the second one we have infinite number of terms. Infinite number of terms. So those sequences having the fixed number of terms are called finite term. Finite sequence. Finite sequence. In this sequence there will be fixed number of terms, but in the next one we have infinite sequence. In case of the infinite sequence, there will be infinite number of terms. So the terms, okay, look at the first one. Terms are normally presented by A. If I say A1, it will be presenting the first one. A1 here is 2. If I say A2, it means the second term. So here is 4. If I say A3, it means the third term, that is 6. Similarly, I can write here A4 is how much? 8. Then A5 is 10. Or for this finite term, the last term is 10. So A5 become the last term. So even you can write L as well. This L stands for last term of the finite sequence. If it is infinite, we can't tell which one is the last. That's why we are not going to use L in case of the infinite sequence. So after this, let me come to the topic, the main topic, arithmetic progressions. So I'll give the example here. 1, 4, 7, 10, 13. So this is also an arrangement of numbers. I have arranged them in an ordered manner by following some rule. So let me tell you the rule now. If I add 3 to the first number, then I get the second number. If I add 3 again to the second number, then I get the third number. If I get 3 again to the third number, then I get the fourth number. Then if I add again to the fourth number by 3, then I get the fifth number. So there exists a relationship between any two consecutive terms. Now consecutive term means now here 1 and 4 are consecutive, 4 and 7 are consecutive, 7 and 10 are consecutive, and 13 and 10 even consecutive. So in case of the consecutive terms, the first one is what you call preceding term. The first one is what you call preceding term, and the later one, the second one, is what you call succeeding term. So in case of these consecutive terms, 4 is the preceding, 7 is the succeeding. Here 7 will be preceding and 8 will be succeeding. Here 13 is preceding, sorry, this is 10 and 13. Here 10 is the preceding and 13 is the succeeding. So in case of this, what happened is, when we find their difference, so 4 minus 1, we get here how much? 3. Here 7 minus 4, we get here how much? 3. 10 minus 7, we get here how much? 3. Then 13 minus 10, we get here how much? 3. So their difference are all same throughout, and this difference is what you call common difference. So the sequence where the succeeding term can be obtained by adding a fixed number to the preceding term, except the first term, is what we call arithmetic progression. So in case of the arithmetic progression, let me just write here some commonly used formulas here. So before coming to the formula, let me just write a1 will be 1. You can write a1 or just a or a1 means here first term, a2 is what, 4, a3 is 7, a4 is 10, then here a5 is 13, or you can write even L as well. L stands for last term of the finite AP. AP means I'm talking about arithmetic progressions. So now we are going to learn something now. What is this AN? When I talk about AN, the term at the nth place. So when I write here A2, the term at the second place. When I say A3, this is the term occupying the third place. When I say A4, this is the term occupying the fourth place. So when I write here AN, it means that term at the nth place. We call it nth term. So this n can be 1, 2, 3, 4, 5. It will be purely a natural number. It just indicates the term at which place. So after that, let me just write here this one. Common difference will be presented by D. This will be given by, how did we find the common difference before? You can take any two consecutive terms. I have taken here A2 and A3. Then A3 minus A2. That means 7 minus 4. You will get here 3. Even you can find in this way. You have taken here conjugative terms A4 and the A3. So A4 minus A3, you will get here 10 minus 7. You will get here 3. So that means D will be given by AN plus 1 minus AN. So let us see here. If n is 4, then this part becomes 5. N how much? 4. Then here will be A4. So we have taken the conjugative terms, and the succeeding one will be written first and the preceding one will be written later, and then find the difference. You subtract it. So D means the term at n plus 1 place minus the term at the nth place. So an plus 1 minus an. So this is the formula for finding the common difference. So I will rub this part now. Now, how do we find the n term of the arithmetic progression? This will be given by a plus n minus 1 whole d. So I'll just show you now. I want to find the fifth term. So okay, let us focus here. Let me find out the fourth term. We have seen that is 10. So let me just write here. We're going to find the fourth term. So fourth term means in place of this n, you will write here 4. A stands for first term. What is the first term here? 1. So you write here 1 plus. We have taken the value of n as 4. That means even here also you will write here 4 minus 1. D value, how much we got before? We got here D as 3. So you will write here 3. So now 1 plus 4 minus 1, 3. This is 3 into 3. So 1 plus 3 into 3, 9. So we get here 10. So there was 10 before. Now we get the value of A4 as 10. That means this is the formula that we are going to use in finding the term at the nth place. So now we have learned two formulas. The first one is D is given by an plus 1 minus an. Now next we have learned this an is equal to a plus n minus 1 whole d. Next we'll be learning some new formulas now. Sn, sum of the first n terms. So I will write this part now. You can take here so many terms. Let me just write here next will be 16 and so on. The AP that I write here is now infinite AP because there are indefinite number of numbers, indefinite number of terms. So it becomes an infinite arithmetic progression. So now this will be, so let me just tell you what is Sn first. If I say here S4, that means sum of the first 4 terms. So what are the first 4 terms here? This, and this. That means from 1 to this 10. So when we add 1 plus 4, 5 plus 7, 12, 12 plus 10, 22. We get here 22. But now we are going to apply a formula and going to find it. Instead of adding one by one, 1 plus 4, 5, 5 plus 7, 12, 12 plus 10, 22. We get 22 here, but we are going to use a particular formula and we'll find it. So I'll give the formula here. N by 2. Twice a plus n minus 1 whole d. So when I say S4, it means that the sum of the first 4 terms. So when I take here n as 4, this n also will be taken as 4. So 4 by 2, 2. What is our a here? 1. 2 into 1 plus. Here n we have taken 4. That means even here also you will take 4 minus 1. D how much? D is 3. So here 3. So 4 divided by 2, of course we'll get here 2. 2 into 1, 2 plus 4 minus 1, 3. 3 into 3, 9. Then here 2 into 2 plus 9, 11. Then we get here 22. So I hope you have learned this. So this formula you should never forget. And now I'll give you one more formula for finding the sum of the terms. We have one formula called Sn is n divided by 2a plus l. So normally this formula will be used in case of the finite arithmetic progressions. Sorry. So now let me make this AP as a finite. If I add from first term till last term, we'll get definitely a number here, and we are going to find this number. So here how many terms we have? 1, 2, 3, 4, 5, 6. That means S6. In this particular AP we have only 6 terms. So when we add all these 6 terms, what will be the sum? Now we are going to find it now. So since there are 6 terms, we'll write here 6. So 6 divided by 2. Here A means 1. Here L means last term. So this is 16. So here 6 divided by 2, 3 into 17. Then we'll get here 51. That means if you add 1, 4, 7, 10, 13 and 16, you'll be getting here how much? 51. Okay, now we'll be learning one more formula for the last time. So before I write the formula, let me just write here S5 and S4. S5 means the sum of the first 5 terms. So 1, 2, 3, 4, 5. When I add from 1 till 13, we'll get here how much? 35. So what about S4? That means 1, 2, 3, 4. Sum of the first 4 terms, we'll be getting here 22. So the relation is like this. The formula is an is Sn minus Sn minus 1. So here I want to find this A5 now. So here A5. In place of n, I'm writing here 5. So here also you will write here is 5 minus is 5 minus 1, it will be 4. So S5, how much we got? 35. S4, how much? 22. So 35 minus 22, we'll get here 13. A5 is 13. And here A5 is A1, A2, A3, A4, A5. We get here 13. So this is a very useful formula. So whatever the formulas that we learned before, I'm going to write here one by one. First, D will be given by an plus 1 minus an. Second, an is a plus n minus 1 whole d. Third, Sn is n by 2 twice a plus n minus 1 whole d. One more again, n by 2 a plus l. And here an is again equal to Sn minus Sn minus 1. And one important point here, common difference D can be positive, it can be even negative, or it can be even 0 as well. So I hope you have learned something today, and we'll be meeting again in the next video. Thank you so much for watching.